Now moving on to 21, we have another solving scenario. And this is where I suddenly have a square root mixed in with some operations. So if we think about that chart that we've been working with of x only, x squared only, x squared and x, well, where do square roots fit into that? Well, we move our directions off to the side. Square roots really fit in at the top. So if we have a square root, we first isolate the root. So we're going to add or subtract anything that's on the outside of the root. We'll multiply away anything that's on the outside of the root. There may be addition or subtraction underneath the root, so leave that alone. Once you isolate the root, then you square both sides to undo that square rooting, and it will dump you into an x squared only, or an x only, or an x squared and x situation, depending on the makeup of your problem. So if we go back and look at 21, isolate the root, subtract 2, square root of b squared is equal to 0, undo square rooting by squaring. This one is rather uneventful because it ends up being 0. If we look at number 23, just as a quick example, you would have the square root of 3x equal to the square root of 2x plus 1. In this case, you have two square roots. They are isolated, one on each side, which is what we want. When there are two, one on each side, go ahead and square both sides. The roots and the squaring cancel, and you're left with 3x is equal to 2x plus 1. Very quick to solve. The only thing we have to worry about with square roots are extraneous solutions. And the key in extraneous is extra. Again, we are squaring, we are potentially introducing answers that shouldn't exist. So you always have to take and check your answer with the original. Can I put 0 under the radical? Yes, that's good, we're okay, no extraneous solutions. You can never have the total value, total expression of your radical be negative. So whatever I put in here for x, after I multiply it by 2 and add 1, it must be positive, or I cross it off as an extraneous solution. So be sure to watch out for those. So let's also look at 27. So that is the square root of 56 minus p equals p squared. Since 56 minus p is all under the radical, whoops, it's just equal to p, sorry. All under the radical, my radical is isolated. I undo by squaring, and so I end up with 56 minus p is equal to p squared. So I'm in that p and p squared situation. I never want to factor with a negative p squared, so I'm going to move both of these over here. So I'm going to subtract 56 and add p. So I have 0 is equal to p squared plus p minus 56. Well, what are the factors of 56 that will add or subtract to make 1? This will factor into p plus 8 and p minus 7. Again, quick check, positive 8p, negative 7p, positive 1p, 8 times negative 7, there's my negative. So now I set each one of those equal to 0. P plus 8 equals 0. P minus 7 equals 0. Subtract 8. Add 7. And it would seem like I am done, but I need to check for extraneous solutions. So if I take 7 and I put it in here, 56 minus 7, that's going to be positive. This number out here is positive. Life is good. That's an answer. When I take negative 8 and I put it in here, 56 minus 8, okay, that's positive, life is good. But when I put it in here, I have a negative. And I can't take the square root of a negative number, square root of a number, and get a negative answer. That can't happen. This is an extraneous solution, so I cross it off. So my only answer is 7. So just be sure to always, again, check your answers back to the original to make sure you didn't introduce something that doesn't work.